Hey guys, I'm going to go through a few examples of problems that you will see on your quiz on Thursday with molar mass and mole conversions. All three of the problems that I'm going to do today are found on your Magic Square homework. I'm just not going to tell you which numbers they are. But if you do your whole Magic Square, or if you take a look at it, you should be able to find the problems pretty easily. All right, so we're going to start off pretty easy. We're going to start with this one that says, what is the molar mass of nitrogen? So in order to find the molar mass, the first thing I need to know is the chemical formula for nitrogen. So nitrogen is a single element, but what I need to remember is that it is a diatomic molecule. So remember that Haber-Finkel acronym we had? The N in Haber-Finkel stands for nitrogen, which means when nitrogen is by itself, it's not just N, it's actually going to be N2. It's really important to remember your diatomics when you're doing molar mass, because if I don't add this 2, my molar mass is going to be wrong. In the future, if your molar mass is wrong, that could mean that you actually get an entire problem or set of problems incorrect if you don't remember that. So now that I have my correct formula and I know it's N2, I can go ahead and find my molar mass. So remember, there's 3 steps. The first step I'm going to do is I'm going to count how many atoms I have of each element. So for this one, I just have nitrogen, and I have 2 nitrogens. So that's my first step. My second step is to look on my periodic table and find my atomic mass for nitrogen. So if I look on my periodic table, I find nitrogen right up here, and the atomic mass listed for it is 14.01. When you're writing the atomic mass, make sure you write the whole number. We don't want to round it just yet. So I'm going to do 2 times 14.01. If you plug that into your calculator, you should get 28.02. If I were doing a compound that had more than one element in it, let's say there was also oxygen or hydrogen, something like that, I would also have every single, and then when you're just going to add up the totals that you get for each element. Since I only have one, I just have one element in this specific problem, that is actually going to be my answer. So my answer is going to be 2802. Please be aware that on your Magic Square homework, for this problem we don't have Sig Figs. Our Sig Figs depend on what our periodic table told us. So when you're looking for the answer for your Magic Square, just keep in mind that your answer should be really close to 28. Alright, so let's go on to this next problem that I have here. Slightly more difficult, but not too bad yet. So this question says, what is the number of moles in 79.9 grams of bromine? All right, so I'm starting with grams, and I am converting to moles. If you remember from our notes, we had something that looked like this. Molar mass in grams. This is really your roadmap for what you need to do to solve these problems. So because I'm given grams, I'm going to be starting over here and moving to this side. Okay? The only things that should be in my problem are my original number, molar mass, and a mole. If you notice, I don't have Avogadro's number written anywhere. I don't need Avogadro's number to solve this problem. Okay? I can solve it just using molar mass, just knowing that molar mass equals 1 mole. I can solve this problem. All right, so I'm always going to set this up the same way. I'm going to start by writing what I'm given. In this case, it's 79.9 grams. All right, and then underneath my given number, I am always going to keep that blank. Let me just draw my boxes here really quick. I'm always going to keep that one blank because that number is really over 1. The 1 under here doesn't have a unit. We don't need that one, so we're just going to keep it blank for now. So this is what I'm given, and I need to get to the number of moles. So I need to make sure that my final unit after I do my dimensional analysis is moles. In order to get to moles, I have to cancel out this unit of grams. If I go back here, I notice that the only option I have is to use molar mass. Can't use 1 mole to cancel out grams because it's not the same unit. I have to use my molar mass. So in order to find my molar mass, just like the previous problem, I need my chemical formula for bromine. Once again, bromine is diatomic, meaning there are going to be two atoms anytime bromine is alone. So it's not just Br, bromine is actually going to be Br2. That's Br in Hoberfinkel, right? So in order to find my molar mass, I'm going to take I'll do this down here. I'm going to take bromine. I'm going to count how many I have. In this case, I have 2. If you did not know that that was diatomic, your molar mass is going to be wrong, and your answer to the problem would be wrong. So it's really important that you remember your diatomic molecules. So I have 2 bromine molecules. I'm going to multiply that by the atomic mass that's on my periodic table. Bromine is over here, atomic number 35. And I see that the atomic mass is 79.90. So I'm going to take 2 times 79.90. All right. I'm going to plug that into my calculator. And you should get 159.8. So remember, once again, if I had a compound with multiple elements, I would have to do this step for every different element and then add up my totals. But I just have one element again. So this is my molar mass for bromine. Again, molar mass is in grams. It's actually the grams per 1 mole, right? In this case, I need to make sure that the grams for that are on the bottom. So I'm going to put 159.8 grams on the bottom. And I'm going to put, and this way, I have grams here and grams there, so that's going to cancel out. And I need to put 1 mole at the top. I have 1 mole at the top, which is great because that is the unit that they asked me for. So I don't want to cancel out that unit. I want to keep that unit. So that's how I know that I'm done setting up my problem. And I can go ahead and do the math to solve it. So in order to solve these problems with dimensional analysis, think of them like fractions. You're going to multiply across the top, multiply across the bottom, and then divide at the end. So if I have 79.9 times 1, it's just going to be 79.9 over 159.8. Plug that into your calculator, and you will find that your answer should be 0.5, right? Now that would be a great answer, except for we need to worry about Sig Figs. So take a look at this original number that they gave us. This original number has 3 Sig Figs, so I need to make sure that my answer also has 3 Sig Figs. But I can't change the value of my answer. I still want to keep it as 0.5, but this only has 1 Sig Fig. So in order to get to 2 Sig Figs, I'm going to add 2 zeros on the end. So my final answer is 0.500 moles. Always make sure you also have your unit on there. All right. Hopefully that one didn't seem too bad. That was, again, just a 1-step problem. Now we're going to move on to a 2-step problem. We are actually going to have to do multiple conversions for this one. So this one is asking how many formula units are in 692 grams of chromium 2 phosphate. What I remember in is number is always describe the particles, atom, molecule, units, those things. We can convert into mole, convert from 1 mole to thing. You notice arrows are that not equals to mass. In order to get from mass in this case, the steps. Step is convert to moles. I'm starting side, and I'm going to convert to moles, and then I'm going to convert from moles to particles. So that's 2 different steps. This little diagram always helps me to kind of remember where I'm at and what steps I have. It also gives you all the possible things we can use to convert. The only things that can come after our initial given value is the molar mass in grams, 1 mole, or Avogadro's number particles. Okay. In this case, the particle we're dealing with is formula units. That just means that our substance is ionic. All right, so let's go ahead and get this set up. I'm going to start by writing what I'm given. I am given 692 grams. That's always going to be written at the top. And on the bottom, it's always going to be empty. Then remember, I'm starting on this side. So my first conversion, following the arrows, I have to go from mass to moles. Right? I eventually want to get here, but I got to get to moles first. So I need to cancel out grams and convert it into moles. In order to cancel out grams, I want grams on the bottom here. My grams, my number of grams, is going to be whatever my molar mass is. So let's go ahead and find our molar mass. We actually have a larger compound this time. We have chromium 2 phosphate. As I said before, this is ionic. So remember, for ionic, we're going to crisscross to find out our subscripts. So we're going to start with chromium, which is Cr. It's a transition metal. So the Roman numeral tells us the oxidation number, which is +2. Then I have phosphate. Phosphate is polyatomic, which is going to be PO4 -3, I believe. Bad chemistry teacher right now, and I don't remember. PO4 -3. All right, then I'm going to my C per O2. My photos, I'm just different elements that I'm dealing with. Okay. Mass, we'll go through, count them really first. So let's chromiums. There are phosphate. This side of phosphate, this is phosphate. The two side of this applies to inside, and I apply but there is. So that means there is. And to figure out 2 times 4, so I get 8 oxygen. So as you can see, this is a much larger compound than other ones, which just means that our molar mass is also going to be larger. Okay. So once I have my once I've counted all of my atoms, then I can go ahead and look these up on my periodic table. So if I look on my periodic table, I find the atomic mass of chromium to be 52. 52.00 actually. Phosphorus is 30.97. And oxygen is 16.00. Again, all I did to find those numbers is I looked on my periodic table to what the atomic mass was. It's always going to be the number with a decimal on your periodic table. All right, now that I have these in here, I need to do a little work on my calculator. So I'm going to go ahead and multiply 52 times 3, and you get 156. 30.97 times 2, you get 61.94. And 16 times 8 is 128. Because I have multiple elements for this one, I have to add all of these together to get my molar mass. So I'm going to add 156 plus 61.94 plus 128. And you should have a total of 345.94. So that tells me the number of grams in 1 mole of that substance. So that was a little detour we had to do in order to get to moles. But I actually need that number. I won't be able to solve the problem. So let's go back up here and look at this. I'm going to take that number I just found, 345.94, and I'm going to put it at the bottom of this next box so that my grams can cancel out. And like we said, this is the number of grams in 1 mole, so I'm going to put 1 mole at the top. And that was my first step. But if you read the problem, it's not asking for the number of moles, it's asking for the number of formula units. So I need to continue to my next step. I have my moles now, right? That's the unit I'm left with. But now I need to go to particles, or to formula units specifically in this case. So from moles, my options now are to use 1 mole or Avogadro's number. I need to cancel out moles in order to get to formula units, so I'm going to put 1 mole at the bottom here. And I know mole is 0.010 to the case 4 units. Now that from each of those units with unit really at the end. This fortunately to my calculus. I do second for scientific again. I'm sure it's calculus. If you're using yours may slightly different. I'm going to start by putting in 0 to look EE, capital E, this instrument will look like. if you have a different brand of calculator, you're going to have to figure out the best way to plug this into your specific calculator. But I'm going to choose the EE function, and after that I'm just going to put in the exponent. Notice I don't have to add a caret or anything to make it an exponent. It's going to do that automatically for me. If you enter it this way, you don't need parentheses. But if you don't have that option, you can enter it times 10 to the 23rd the way it looks, but you have to have parentheses around it or you will not get the right answer. So I'm going to multiply across the top. I have Avogadro's number times 1, I don't have to put that in my calculator, times 692. And I get a really gigantic number, right? I get 4.16584. Remember the E stands for times 10 to the 26th. And I'm going to divide that number by 345.94. 0.94. And you get a really, really large answer. So let's go ahead and figure out how many significant figures I need to have. This number that we were originally given has 3 significant figures. For scientific notation, that means whatever's at the beginning, before the times 10, needs to have 3 significant figures. If I look, that brings me to the 0. I'm not going to round up because it's a 4, so my answer is going to be 1.20 times 10 to the 24th. Now keep in mind, this is a very, very large number, right? Large positive exponent. And that should make sense with what it's asking us for. And it does, because it's asking how many formula units, how many individual particles of chromium phosphate are in 692 grams. This is a large amount of that compound, right? I would expect there to be a lot of particles if I were to look at the individual molecules, so to speak, or the individual atoms that are in that. It would be very, very great, right? So it makes sense that my number would be so gigantic. So this should be your final answer for this problem. Hopefully that helped you a little bit. Please make sure to finish your magic square for Thursday, and you also have a quiz on Thursday. Go ahead and fill out the survey at the bottom to prove that you watched this video and that you did the problems along with me, and I will see you back in class soon.